Hello and welcome to part 23 of the mod making series for locked loop containers. And as you can probably see to the bottom right, it is extremely late. Well, not that late, I guess, but pretty damn late. So this one is going to be real short. So once again, I didn't get too much done coding, but I did get more so done than yesterday. But this was more, once again, kind of like testing and experimentation kind of stuff to gather information that I will use later. Because all that information we had yesterday from the console and stuff, while it was useful, it's not very useful to actually like implement into, say, something like this that is going to be automatically going through it. The code is, or whatever, the computer is going to be processing these values that we give it. So those basically quote unquote raw values that we were giving it, or that we were receiving and reading, that may be useful to us, but to the computer it's really completely useless. Like, it's not useful unless we give it some kind of distinction or whatever filter, like basically tell it do this and then identify this with that kind of thing. Like, we can't just tell it that, oh yeah, the door model, that's a door model. Like, we have to tell it something that distinguishes the door model, or that specific one, from all the others, as well as all the other models. And in this case, I was like, okay, so I'll do that today. And that's what I did, basically, is that I used some gathering of information using those same values to basically figure out in what ways I could retrieve useful identifying values, or give useful identifying values, unique ones, quote unquote, to the computer when I need it, based on whatever those physics overlaps actually get from the, like, say, the model, that they were receiving the game object name and stuff, which was called something like mesh and then a number. Well, that whole string of that, like Daggerfall mesh, whatever it was called, that is not useful. I mean, it could be useful to the computer, but to what we want to do, we don't want it like that. So basically what I was doing was figuring out ways to get something that is more just a number, more than like the actual like identifying number for the model itself, rather than all that other stuff. And what I came up with is that the model, at least, I don't know if everyone, but most of the models seem to have this object attached to them called the mesh filter, which is some Unity object that is a part of the whole mesh rendering, like, framework, whatever they have, that, like, the entire thing about meshes and like textures and models and vectors, whatever, all that stuff about rendering and everything. That's a component that was attached to all of these models I saw. So I was like, okay, let's see if I can get that component from these particular game objects that we're going through. And that's what I did. And then I did an if statement afterwards of getting that component to make sure that it does not try to use this mesh filter or go through the rest of this unless it finds a mesh filter game object, or a mesh filter component attached to that game object. Because otherwise, if there isn't one for whatever that game object is, and then you try to do something with it, then you'll throw an error. So it's like, okay, just first thing, make sure that that value is not null, basically, which filters out a few of the other ones that for right now we don't care about, such as the enemy entities and stuff like that, which we will care about later, but for right now we just wanted to worry about the models. So those, the entities and stuff, the enemies, they're getting ignored in this case. But the models, as well as some billboard objects like loot piles, I think, as well as some other billboard related things, are also being found, it seems, in this. And I basically like just did all this other stuff. I don't really feel like explaining it like too much right now, but basically these things that I have defined here are for just a few lines down, where I did something with those text values that I was retrieving from this using this thing. I was making a new string and calling it mesh name, and it's becoming equal to this mesh filter component that we were finding. And then if we did mesh filter dot mesh, that is actually a component within that component, the mesh itself, I guess. And then we could find the name of that mesh, which would give the model ID in this case. It would give the model ID a space and then instance at the end of it, like the word instance. So it was like 55012 space instance. So that was much more concise than what its original name was. So I decided, well, okay, let's go with this to actually like try and get this model ID that we want alone by itself, which is what I did the lines after here. I have mesh name, the actual string that we just have defined there, dot length, which is the length of how many characters, or that's, at least that's the idea, is that how many characters are within that string of text, and make sure that it's greater than 0, because if it's less, or if it's 0, doesn't have anything in it, we don't care about it. So just get those out basically and prevent more potential errors later on in that case. And then I was doing this thing called substring, which is like a string, a text manipulation sort of function, which essentially what it does is, if you have a string, in this case we have mesh name dot substring, you call this method, you give it, the first value is the index, or basically the what character within that string, like what character, yeah, what index within that string you want to start. Basically the parts that you care about in that string that you don't want to remove, you start there, kind of like you start there essentially. So in my case, I care about the entire string. In this sense, I care about the entire string that we're going through here, the mesh name. I know this already because I saw the string of text and I'm like, okay, I want the whole thing. So the substring, we're giving it the value 0, which is the first index value, the very beginning of that string of characters. That's 0. Now, if I wanted to start at character 10 of that string instead, and then remove the anything behind 10, then I'd put 10. But in this case, I want to start at the very beginning, so I put 0. And then after that, I could put another argument, which is the length that I want it to continue after that value. So anything that goes past that length afterward within the string of characters, that will be deleted as well, or ignored, whatever you want to call it. And the only part of the string that will be kept is the parts that are between the initial value, the 0 here, the index start, the beginning index, and then the length after that. But then anything that goes over that length and the index, the start index, that will all be removed from that string of characters. So, say in our case, what I'm doing is I'm wanting to keep those first characters of numbers, like 55012 or whatever, and then I want everything else to be taken out of it. That being the space and the index. The space and the instance word. So it's only leaving the numbers, which is going to be our model ID. That's the ID at least. So what I did there was I did mesh name dot length, and then I did -9 because I just counted how many characters are after the numbers. In this case is a space, which is 1, and then 8 more for the word instance. So -9, and then that allows me to essentially keep only those numbers and then remove the rest. That is what this whole substring there is to do. And then after that, I do something else called a try parse, which is kind of a weird word. It's essentially there to, or in this case, it's int.tryparse. Essentially, what this is doing is it's taking something of a type. In this case, it's taking a string type value with a value that is supposed to be a text string, and then it is spitting out another type of value made from that, essentially. So we are taking in a string of characters, and we are trying to get out from that a string or numbers. We're trying to get out numbers. And while to us that might make sense, that we would say, well, what's the difference between 55012 as a string and 55012 as an int or as a number? Well, it is quite different, because that string can be represented only as a string, essentially. Like if you tried to add say 20 to that string of numbers, then it'll be the string of numbers, but then it'll just be adding the 20 as a string to the end of it, like putting two words together, like just smushing them together. And that's obviously, well, maybe in some cases, but in this case, that's not what we want to do. What you probably want, or at least what I'd want to do, is to add 20 to that number, not the string, not as a word, as a number, as an addition. So that is why I'm doing this try parse thing. It is turning a string into a number. It is turning a string that looks like a number into an actual number that can be used later on for actual mathematic operations, mathematic formula, whatever. Yeah, that's exactly what's happening here. Is that try parse? It's taking in this string that we have, and then it is spitting out that same thing, but as a number instead. And one thing with try parse that's nice is that if it gets something that is not a number, it spits out, it doesn't spit out an error. It instead just basically handles it within itself and just gives you a bool value, like a false, like a true, and it would spit out, it would give you a true value, in this case, this valid ID thing that I have defined up here. If it does properly convert that string into a number, then it returns true. If it doesn't, if it's not able to, like if that string is actually a thing of letters instead of numbers, then it will return false. So there'll be no errors or anything like that. It'll just be false, and you won't get a number back because it's not a proper number. And that's, in my case, what I want. Which then right afterward I do an if statement. If valid ID is true, then continue here, else do something else. And then I just basically print out what I've just been talking about. Overlap found on game object, and then I'm returning the model ID that I just got as a number, and it writes it out like that. And then with mesh filter name, that's just the whole game object name I have. And then as mesh name, and then the name that I just basically cut down to what I wanted, essentially. And then I have right after that, here's the model ID plus number plus 20. And then it actually does that mathematical operation properly. So it's, if it was 55012, it's now becomes plus 20 to that, so 55032. But then after that, I was like, wait, well, what happens if I do mesh name plus 20? That is a string plus a number. And it did as I expected, where it does the actual like name, and then it just smushes a 20 at the very end of it as a string. And then the else I just have for other things, but probably better I could just show it as a screenshot I took of the Unity console. So you could see here that one of the first things that was found was a not model, or something that was a billboard instead of a model. So we have overlap found on game object, billboard, blah, blah, blah. So that was the else part there happening. And then right after that, we have overlap. Here, I'll just highlight the whole thing here. Overlap found on game object 55002, which is a door. In this case, it is one of the types of doors with mesh filter name, Daggerfall mesh ID, same thing, but all that other crap, and then end mesh name with the 55002 space instance at the end, which is what we broke down it into this one 55002 by itself as a number. And then we did the mathematical operation 55002, yeah. And then we did the operation of here's the model ID number plus 20. So now after that, we are showing that it is a proper number by adding 20 to it. So now it became 55022 instead of 55002. And then we tried the thing after that, which was what happened. I wonder what happened. What happens here, I wonder. Which we just did a string of that number plus 20, which it did that instance just 20 just smushed onto the end like that. So that's the kind of difference you could see between an int and a string in that sense if you try to add them. And which is why I had to do that I wanted to do that try parse thing, because now knowing this model ID, there is many cases where I can actually, like for the doors especially, where they kind of go in sequentially on their like actual model numbers. So like one comes right after the other, basically in a sequence. So I can make it much more concise and easier to go through those model numbers and say like use these ones instead of these ones, or use these ones and then stop here. I can instead just give it a number between these two values, which is really like pretty quick and really pretty efficient and everything, easy to do, instead of giving it like every single individual thing as a string or something like that. So that's exactly what I wanted to do in this case. And then you could see a few more examples here, like down here, 41042. I think that's the lectern activator thing for that one room with the imp, and the skull circle or whatever, the one that you click the lectern, whatever the hell you call it, and then it slides open that little secret bookcase for the two loot piles. And then I did plus 20 to that and all that. And yeah. That's what I did, and I was, even though it didn't feel like I did much, and I did start doing this way too late. I'm glad I did, because I'm definitely gonna be, this is gonna be definitely very useful to me when I start doing the filtering through these actual objects and trying to like identify them through this automatic process. And I'm going to do this similarly with the other objects as well, such as the enemy entities or whatever yeah, this basically just the enemy entities in that case. The billboards and the models, including the doors, those being models. So basically those three main things I'm going to be trying to use in that physics overlap, and then try and help use them to contextualize the loot piles and stuff. And all this stuff that I'm doing with this context thing, I'm almost definitely gonna try and add a setting later on, so you could turn it off if you want. Just because I don't think it's really gonna do much negatively to performance at the end of the day. Like there might be a tiny bit extra load time, like a real tiny bit of load time in reality, added to when you go into a dungeon or something like that, depending on how many loot piles there are for it to go through. But if somebody doesn't like that, I'll probably make a setting just to be like, hey, if you want a simpler, if you want a simpler version of this, you can just deactivate this. If you want it to be more complex and quote-unquote more interesting and more logical, whatever, then keep it on and all that stuff. But yeah, that is what I did today, and I'm for how little it seemed like I did, I'm pretty happy at the result, and I'm glad that I did it. So now this will be much more easy to do for the other parts of these checking things, and then I'll make it more clean and everything and all that. So I like this method so far for doing this part at least. Before this goes any longer, I think that's it for today, but thank you very much for watching, and yeah, I'll see you in the next one.